myself Sabina Devi, Assistant Professor, Department of Physics. Now I am going to explain about Hall effect. So we all well known about semiconductors, right? Okay, so we know that semiconductors, it act as both conductors as well as insulator, right? Okay. So at 0 Kelvin it acts as an insulator, while increasing increasing temperature or increasing energy, it acts as a conductor, right? Conductivity also rises, right? Okay, so based on impurity we have two different types. So that is called as extrinsic semiconductor. In extrinsic we have two different types, right? P-type semiconductor and N-type semiconductor. In N-type semiconductor we have added pentavalent impurity. So here the majority charge carries the electron and minority will be holes, right? So in P-type semiconductor we have added trivalent impurity. So here the majority charge carrier holes and minority will be the electrons, right? So these are all seen in previous video. So now I am going to explain about Hall effect. So Hall effect is nothing but it is used to distinguish between the conductivity is produced due to electrons or holes. Okay. So we know that in the semiconducting material we have two charge carriers, right? Holes and electrons. So in semiconductors, so it starts to conducting means. So the conductivity is whether the conductivity is produced due to electrons or holes. So we don't know the factors, right? So it is easily determined by using this Hall effect. So that material will be P-type or N-type, or the majority charge carriers will be holes or electrons. This will be determined by using this method. Okay. So here let us see the Hall effect. So what is meant by Hall effect? Okay. So we have, let us consider a current carrying conductor. So this is the current carrying conductor. So let us consider the current carrying conductor. It will be P-type semiconductor or N-type semiconductor, anything else. Okay. So we have three different dimensions, right? So now current is applied in X direction. Okay, in X direction we have applied current, and in Z this is Y direction. This one is Z direction. In X direction we have applied current. Okay. So in Z direction we have applied magnetic field. Okay, so let us consider a current carrying conductor. So in x-axis we have applied current through the x-axis. Okay, so in z-axis we have applied magnetic field. So here the electric field will be produced in the sample will be in the positive y direction. Okay, so this is said to be Hall effect. This is nothing but let us consider a current carrying conductor. So current is passed through the x-axis and perpendicular and the same time magnetic field is fit to the z-axis. So then here the EF is produced in y-axis. Okay, so that produced electric field will be perpendicular to both current and the magnetic field. Okay, this is called as Hall effect. So current carrying conductor is placed in the transverse magnetic field. So the electric field produced in the conductor is, that means, perpendicular to the current and the magnetic field. So this is the Hall effect. Okay, we have in Hall effect we have two types of semiconductors, right? P-type semiconductor and N-type semiconductor. Okay, so now we are going to see about N-type semiconductors. So in N-type semiconductor, majority charge carriers are electrons. So how be the electrons will be the charge carriers? It will be seen by using this video. Okay. Okay. So now we have seen about Hall effect in N-type semiconductor. So let us consider a N-type semiconductor. So this is the conducting material. So let us consider a N-type semiconductor. So which is kept at the transverse magnetic field, right? Okay. So in N-type semiconductor, majority charge carriers are electrons. Okay. So electrons are located on this side. The minority charge carriers are holes. Okay. Okay. So now the current is applied through the positive x direction. So now the current is applied through positive x direction from left side to right side. Okay. So now the electron dimension will be the right to left. Okay. So electron dimension is in from right to left. Okay. So now magnetic field is applied in z direction. So what will happen means, so this magnetic field, so the current is applied through the positive x direction. The current direction is from left to right. Okay. At the same time, we have applied magnetic field in z direction. So what will happen means, so this electron majority charge carriers will be attracted by this magnetic field. So these majority charge carriers moves towards downward direction. So it will create the potential difference. The minority charge carriers will be moves towards upward direction and majority will be moves towards downward direction. So due to the potential difference, so we have the Hall voltage will be developed. Okay. So due to this potential difference, here we have Hall voltage will be developed and the electric field will rise in the positive y direction. So this is the Hall effect in active semiconductor. The derivation parts will be explained in later videos. Thank you.